Hey, what's going on? Welcome to AngularAir. I'm your host, Justin Schwarzenberger. And on today's episode, we are going to be talking about and diving into policy-based client-side encryption in Angular. I don't believe it's a topic we've covered here on the show before, so pretty exciting, pretty advanced. We're excited to get into it, so we'll check that out. Before we get into it, though, we got to make a mention of Angular Connect. I mean, it's like right around the corner, a couple weeks away. November 6th and 7th in London, Europe's largest Angular conference. You can still get tickets for it. So if you're in that neck of the woods or want to get there, check it out. Definitely go check that out, angularconnect.com. I believe we have some speakers on our panel here that'll be there. So always a good time. Check that out for sure. Let's get into it. Say hi to our panelists, then we'll meet our guest. Joining us today, we've got a full panel crew. Alyssa Nichols with us. Alyssa, what's going on?
Hey, everybody. Really glad to be here.
Glad to have you. Austin McDaniel, what's happening, Austin?
Hey, everyone. I've missed you all. That was kind of creepy.
I think the audience is all saying, we missed you too, Austin, but I can't tell for sure.
Or they're all just creeped out.
Bonnie Brennan, how's it going?
It's great. It's great. I missed everybody. I'm so excited to have a full panel tonight. And I'm excited about this topic because this is something I know nothing about. So I'm going to be much smarter here in about an hour.
Awesome. Awesome. Mike Brocky, what's going on, Mike?
Not too much. Happy to be back. I just want to be a little bit different. So I'm just going to say, even though it may not be true, I didn't miss anyone. So
yes, you did. Just you lie like a rug.
I didn't say it was
Mike
true.
has pictures of all of us on his wall, so he just looks at them constantly and he feels comfortable, right?
What about that necklace I gave you with my picture inside of the heart?
I hang it off of my webcam so I see it every time I look at my screen.
I think he dropped that when the Titanic sank. I don't know. All right. And our team guest today is Rob Pinna. Rob, how's it going?
It's going real well, Justin. Thanks for having me. I didn't know I was going to get a little heart pendant, so now I'm really excited.
Yeah,
you're going to love Mike and Austin.
Awesome. Yeah, so yeah, it's great to be here, and I didn't realize I was going to have a full panel either. So you guys outnumber me. That'll be great.
Yeah, I think everybody's very interested in the topic. Why don't you give our viewers a little bit information about yourself before we
Yeah. So I've been doing this a little bit longer than most of the people that I meet in the software business. I got my computer science degree in 1984. It was just kind of a new degree then. So seen a lot of things, and I'm mainly a startup guy. I've done this is my 7th startup, and very, very technical, but kind of go from the product side, and it's a subject that I'm really passionate about. It's kind of all about data privacy, and being able to be smart as developers about how data is being collected and shared, and maintain control over some of our personal data.
Yeah, and it's a really compelling scenario here when we're talking about Angular and we're talking about this client side and these client side applications where all this JavaScript and logic lives in the browser. So now there's a lot more stuff we have to think about in terms of security, right, for that data.
Right. Yeah. So
okay, but before you get into that, can you tell us about the posters?
The posters behind me.
Because I want to hear the story behind the posters.
Yeah. So
what's up with that?
I've got 4 kids, and one of the things that we really like to do is just go see Broadway plays, or we live in Denver, so Broadway plays kind of tour here. So, and then we go ahead and usually there's a poster from the cast that the cast signs, and so we've always kind of made it a tradition to go up and meet the cast and say hello to them and kind of buy the poster with the signatures. So Book of Mormon's my favorite. Wicked's pretty good. Lion King, can't beat that. And we've seen a bunch of other ones as well.
That's awesome.
Yeah.
Sorry, I didn't want to break the flow. I just had to. Yeah.
No, it's great. Yeah, if anybody hasn't seen Book of Mormon, it's definitely the best play in the universe. So it's definitely something to watch. It's the same guys that did South Park. So very good.
I would not have put those two together. The Book of Mormon and South Park.
Right. Yeah. Justin, you were going to pipe in?
Oh, I was just going to ask what's the next poster that's going up there? You have a plan for one already?
Frozen came through and we did not see it. So we kind of skipped over that. My kids are older, so I think I escaped the Frozen period. If you have small kids, that was probably something you had to live through.
Yeah, it's a good thing I've got my headphones on and my girls didn't hear you say that. Because it could have been an issue.
Yeah, probably Hamilton would be the next one. I haven't seen Hamilton yet, and that's something.
I love Hamilton.
Have you seen it?
No, but
No?
I have the soundtrack and I know the words. Awesome. Okay,
Cool.
I can't sing all the words because it goes so fast, but I know the words and I can follow along until to a point, and then I just My son can know.
When it comes through, I'll give you a call and have you get me all prepped.
There you go. I will do that. But first, you have to get us prepped with this privacy thing. Why should we care?
Should I dive in and tell you why you should care?
Yeah.
Okay, cool. Justin, why don't you, if it's okay, can I project my screen?
Yep, let's do it.
All right. And I'm going to, what I thought I'd do before I go ahead and let me hop over here. Are you guys seeing my screen, my browser?
No, we don't see it yet.
Okay, that's because I probably have to click a button somewhere.
If you have more than one monitor, it's going to ask you which view.
So it's usually in the Hangouts, it's like a green screen icon on the left.
Gotcha.
There you go.
All right. So what I thought I'd do is I kind of have a couple of different things to kind of take you guys through. We'll definitely get into some code, and there's a few stack blitzes. These are public, so you can kind of follow along as I go, and but we'll walk through and kind of show concept by concept how we build that up.
Hey, Rob, can I ask you one quick question before you get started?
Yeah.
Because I've been hearing, and I don't know a whole lot about encryption or security or anything like that, but I've been hearing that basically data encryption at this point should be pretty much a standard feature, right? I mean, if you're doing web design, like it's gotten so easy that there's no reason why you shouldn't, like even if you don't have like a super secret website, this is kind of stuff that you should think about doing just by default.
Yeah, absolutely. And I think that there's one thing that is a really, really common question is, how does client-side or end-to-end encryption differ just from HTTPS as an example, which is when people say encryption, that's normally what they think. And we're actually going to talk about something much broader than that. So HTTPS encryption is just encrypting when it's on the wire. But what we're going to talk about is where the data is always encrypted as soon as it's created, and it doesn't get decrypted until it actually gets used. And that's what end-to-end encryption is. And so there's a nuance there that, we'll go ahead and I'll keep coming back to that point. But certainly, I believe that it's pretty critical to build a system like that today. And just full disclosure, I work for a company that's in this business. I work for a company called IronCore. Most of what I'm going to talk about is not specific to IronCore, but I'll call out specifics of where that comes into play. So I'll walk you through some Angular, some stack blitzes, which are like CodePen, if you guys are familiar with that. And then we'll also go through a little sample app, and that's in a public repo. So if there's interest, you can follow along later. But just kind of, if you guys give me a little bit of setup time on slides, I'm going to start there. Let me pull this up. And
I was trying to remember where I heard that name IronCore before, because I feel like I just heard that like yesterday, and I was like, oh, because I was stalking you online because you were coming on the show.
Oh, there we go. Yeah, it's a good name. Everybody likes the name.
It's cool.
Yeah. So just kind of, random, mandatory factoid. The human population produces 2.5 quintillion bytes of data per day. So quintillion is 10 to the 30th. So that's a lot of bytes. And we're contributing to it today with our video and our Slack, but we're not the only ones. And the problem that we're starting to see, with all the different privacy and data breaches that happens is, as software developers, we've been pretty loose about how we handle the data that's entrusted to us. So if I go out and I say, I think, Mike, you said you're from Pittsburgh. Maybe I were to say that I was a Steelers fan. and I go ahead and I indicate that, and all of a sudden that gets shared with Facebook. And I've indicated to the world that I'm a Steelers fan, and that's something that I'm personally embarrassed about. I don't want anybody to really know it, but all of a sudden it's out there in Facebook. So Facebook in turn is loose with that data as well. And you can go ahead and anybody can go ahead and authenticate using your Facebook information. And there's a case called Cambridge Analytica that made the news, where there was an app that would do a personality quiz, and they would associate your likes and your friends and your social network with how you answered certain personality questions. And they in turn sold that data to Cambridge Analytica. And Cambridge Analytica used it to predict how I would vote in an upcoming election, and would target misinformation at me in order to either encourage me to vote or discourage me to vote. So that's kind of an example of how this 2.5 quintillion bytes of data kind of gets out of control. And the key part of it is everybody thinks about this topic as security, and that's actually important. But what I'm talking more about is privacy. And privacy is this idea that once I let my data onto the internet, do I actually have any control of where it goes? And really what we're talking about today is a way to make sure that I have control. So I'm going to pause there and see if that makes sense so far. What do you guys think?
I just need to clarify that I'm not a Steelers fan.
Okay, good.
Other than that, everything else sounds really good.
All right, cool. All right. Are you a Browns fan? Because you said there was some Cleveland in there too.
He loves Cleveland.
Okay, you are a Browns fan. That's okay.
No,
Baker Mayfield looks pretty good, I gotta say. All right. So what we want to do conceptually is when we create data, whenever it gets created, we want to put it in this protective seal. And we're going to talk about a special type of encryption that does that. And so then when we share it, we have the ability to say who can and cannot access it. And we're going to do it in such a way that anytime it gets passed on, we will be able to see who's accessing the data. And the way this works is there's kind of, I call it a phone home. But basically, anytime the data is used, there's a very lightweight service that you go back to give permission to access the data. And so you get a complete transparency into who's accessing the data. And that doesn't matter regardless of where the data goes, any type of cloud service, tape backup, devices, etc. And the biggest thing is if I decide at any point in the future that I no longer want to share the fact that I'm a Pittsburgh Steelers fan because I'm applying for a job and my hiring manager hates the Steelers, I can go ahead and revoke that access. Or if it's an embarrassing picture from my frat days, and this is something that goes to the heart of a privacy right. That if you've heard of GDPR in Europe or the California Consumer Protection Act, there is something called the right to forget. And we live in an economy where our entire lives are recorded. So, 24/7, basically our entire life is there. And one of the ideas that's emerging is human beings should have the right to be able to forget, to erase certain data. And so that's actually being legislated in the European Union. And it's very, very tricky to implement technically. So this idea of revocation becomes important for that reason.
Yeah, I was going to say, this sounds like black magic.
It is black magic. It is. And so, the big question, and that's my setup. And I kind of said I'm passionate about it. I kind of joke around and stuff, but it's actually, I've been doing this for a long time, and I like to start out that way because I like to kind of impress that the stakes are pretty high. It really goes to, how democracy is going. Now we're basically, my refrigerator is now a computer that keeps things cold. So everything is basically connected to the internet. And so we're living in a time where, as a software developer, how you treat data and how you secure data can actually have very significant implications. So that's my serious part of it, and kind of how, and then I go into the fun part of it, which is just how we do it.
And so this is not just like if we're building an app that's a new social network and we're doing that sort of share of that information, but I mean any type of app that we're building that we're collecting user type of data, right, is something that we're passing
exactly. And consumer examples, are a little bit, they're familiar, so a lot of I go to them, but really the application is more B2B and enterprise. So that example of data proliferation that I gave, there are many, many examples I could give, but one of them is from the U.S. Defense Department, and they basically, they put out the specs for a fighter pilot, a fighter jet, and it had all of the blueprints and all of the information. That got shared with the contractor, which got shared with the subcontractor, which got shared with another subcontractor, and that subcontractor got hacked and ended up that China, in this case, got all of that intellectual property. And so the issue there is not necessarily that the data wasn't secure in the first place, but the fact that data gets passed on. I mean, there isn't any application you can write today that doesn't use a bunch of different services and doesn't have a partner ecosystem. And so it's this ability to control data after it's escaped. That's
I think a good way for like consumers to think about this is, we deal with things like DRM for like movies and music and things like that. And it's kind of been controversial, but this is kind of like DRM for my data.
Austin, what's DRM stand for?
Digital rights management. That's a great example. Actually, I've never heard that before. I'm going to steal it, but that's exactly kind of what it is. And it's a direct analog, because in DRM, the idea is that the creator of the intellectual property, whoever created the music, they want to retain control over how that music is used. And so this is the same exact idea. In a way, right now, we're creating all this data that, by the way, is extremely valuable from a monetary perspective, and yet we give our rights away to it. So, great example.
Yeah, and I think another thing is like, your Cambridge Analytica example, right? Like that was pretty controversial in the news and touted as a data breach, and that really wasn't a data breach, right? Like, people were giving that data away.
Exactly.
I mean, you could say it's like morally gray area, but at the same point, for consumers, that are doing this type of thing, they need to be aware of what they're agreeing to. All those Facebook quizzes and things like that, they're just data traps most of the time.
And why
and
do they
you
want
make
my
a really
email address every single time I shop at any store? Like, I can't buy anything without them asking for that. Why do they care so much?
Yeah. Well,
money?
2 points there. I think one is the first one is you made a really good point about in Cambridge Analytica, there's no breach. Basically, everything was by the book. Actually, there are some terms of services that were violated by Cambridge Analytica, but basically everything was by the book. It's really by design. That's how what Bruce Schneier, who's a kind of active person in this area, is kind of a thought leader at IBM, calls the surveillance economy. And that's all by design. And so that's why I kind of make a distinction between security and privacy. It's not necessarily malicious. It's actually, how do we go ahead and set it up so that data can be protected? So that's where we go. And why they ask for your email address is that's actually not, there's not a very good reason for that, because basically they don't need it. They know who you are anyway. They can tell from the cookies that you send, just from the digital signature, the fingerprint. It's amazing what they can do. And they combine many different parts of information and can identify you to a high degree of accuracy.
One of the most interesting things is, how these, like you were talking about, how they can identify you from the cookie, but even further than that, like your credit card numbers, right? Like credit card companies actually sell this info and probably articulate and like figure out what you want to buy before you even know it.
Yeah, there's a famous case of where some gentleman was getting blasted with coupons to his house from Target, saying, talking about pregnancy diapers and things like that. And he was like, he went ahead and, said something to them like, why are you sending this? Well, it turns out his daughter was pregnant, and Target knew it before he did. And, it's like, that's the degree of predictive analytics that you can go ahead and enter into. It's pretty amazing what can be predicted from big data. It's very, very accurate. So should I jump into how this all works? Kind of get into the geeky land and out of the...
Yes.
Okay, kind of good. So I'm going to start with just a concept from Angular that doesn't even relate to data privacy, but it's a pretty cool part of Angular, and it's called HTTP Interceptors. And just about every framework and every language has some type of middleware concept. Middleware is a way to kind of to customize or extend some core functionality of a framework in a way that doesn't interfere with anything else. So
can I just tell you how happy I am to see you blogging on Angular in depth, because I've been spending a lot of time on that site in the last couple of weeks, and I love that. I love it. Love it.
It's a great site. It really is a great site. And I actually, the Max, who goes ahead and runs the site, I found them when I was researching this article, and he has this really good insider's guide into interceptors and HTTP client mechanics. And so then I emailed him and said, hey, would you go ahead and post this article? And he was like, he was graciously went ahead and posted it there. So that was kind of nice. A great site. Yeah.
I'm a big fan.
Yeah, he's great. So I'm going to go ahead and show you a stack blitz with an HTTP interceptor. And the first one I'm going to show you, let me go ahead and this is how, and Justin, you mentioned font size. Is that readable from your side?
Yeah, I think right there is good. Yeah.
Okay, great. So this is, I'm going to go ahead and expand out, and this stack blitz, which I don't know how to tweet these out. Actually, I think I have a colleague kind of listening in. Maybe they can tweet with a hashtag for AngularAir. And
what's your colleague's name?
Madison.
Hi, Madison. We love you, Madison.
She's great. She's great. Yeah. So what we have is a kind of, just a very simple app here. And we can go ahead and write our logging interceptor. All this is going to do is say, hey, a request has been intercepted. And so you can see, very, very simple. I import HTTP interceptor. I implement the interface, and I'm going to get called with this intercept function. And I get passed a request on the way in, and it's kind of like an onion model, I call it, where you call the next layer, and then you can respond on the way back out. And I'll show you an example of that in a second. But all we're going to do is just going to say, hey, we've gone ahead and got a log. We've got a message. So let's go ahead and see that in action. Let's wait for this to spin up. Come on, you can do it. There we go. So I'm just going to make a request, and we'll see. Sure enough, we went ahead and made a request to our REST API, and our interceptor is in the way, and it says that API quotes 1 has been intercepted. So all I had to do was write this interceptor, and then I had to register it in app.module.ts, which we all know and love. So the way that works is it's just very declarative. I'm going to come in here, and it's this line right here where I set up a provider. So we're going to go ahead and use that concept to slide in an interceptor that does this very special type of encryption. And really nothing else about the application is going to change except how we configure the policy for the interceptor. So I'm going to show the mechanics of how we do that first, the next step of this, if you will. And you can read about it in the article too. Here again is another picture of an interceptor. We're wrapping an HTTP service. We intercept requests. We get a chance to modify the request and the response.
Interceptors are one of my favorite parts about Angular's HTTP. They're so powerful because you can do things like error logging, like I think you have there, where, you know, if, you know, an endpoint fails, you can, you know, attach JWT tokens, you can hook up analytics. There's so many things you can do with it, and so cool. And I hardly ever see anyone like talking about them, so I'm super pumped.
Yeah, and it's it is really cool, and it's not that hard either. It's like, you know, on a scale of you know, hello world to observables at the top, you know, it's kind of like a third of the way up the scale. You know, it's not a very difficult thing to get wrapped around. So so very approachable. Bonnie, I think I cut you off. You were going to say something.
I was talking about black magic and interceptors.
Oh, okay, cool. Yeah, it's a good black magic thing. So I'm going to show. So what we've done is this could be done with a lot of different encryption technologies. I'm going to talk about what distinguishes Iron Core at the end. That'll be my commercial. But you know, you could do other types of encrypting interceptors here to do end-to-end encryption. But I've just added a second interceptor, and kind of the first rule of interceptors is first do no harm, right? So what it's going to do is it's going to pass most things through unchanged unless I tell it that this data is sensitive, because not all data needs to be encrypted, right? You know, there's a big difference between things like personal health information, like my blood test, etc., versus, you know, just you know, my favorite cat meme, you know. So some of that's sensitive, some of that's not sensitive. So if I go to I'm going to close this one down so I don't get confused by it. Let's see which ones are which. Okay, this is the nothing encrypted one. Good. So what I'm going to do is what we've done here is all we've done is we've gone ahead and we've added this second configuration mechanism. And if you go out and look at our repo, you'll see this iron directory, which has all the Iron Core stuff in it. This is kind of sliding into an NPM module in the near future, but we thought it would be interesting. You know, some people really like to look at what's going on underneath the hood. And if there's interest, I'll take you through what the Iron HTTP interceptor actually does, but you don't need to understand it to use it. But it's a pretty interesting application of observables and pipes, and you know, if that stuff is very interesting to you, it's a good thing to dive into. But I won't cover that unless there's interest. So if I go take a look at this, like I kind of said, the first thing is first do no harm. So all I've done is I've added this encrypting interceptor, and what I'm going to do is make a request. Come on. All right. And what we'll see in the console here, in the developer console, is that the interceptors logged a couple of messages, and it looked at the request, and in this case, it was asking for a quote from the API, and I think we have a Ben Franklin quote: 3 can keep a secret if 2 of them are dead. It's kind of a good secrecy quote. And what happened is there's this thing called an iron policy that's attached to the request. And the title of the talk is policy based. And I'm going to talk about the concept of policy, how it works and why it matters so much. But just how it works is that there's a little policy that's kind of put on here. And the policy in this case wasn't there. So it kind of defaults to a policy that says, hey, don't do anything. And lo and behold, the body of the response and you know the is left alone, and I go ahead and get what people call a plain text, and so I just get that back. 3 can keep a secret if 2 of them are dead. So that's the first do no harm. Now what I'm going to do, and I will pause for a second here once I set this up, but in the article we walk through this. The next thing I'm going to do is I'm actually going to run one that actually does do some encryption, and let me kind of check in with you guys. How's this going so far?
Yeah, it's going good.
Okay, good. All right. So what I'm going to do now is I've got a third stack Blitz, and in here, I'm going to show this later on, but we've got we've added a class that we're storing in our back end, and I'm going to show you a little example using Star Trek. because that's for my generation later on. But what we've done is this particular order class, using Angular best practices, we have a REST endpoint, and it's mapped. Actually, I lied to you. It's in the GitHub repo. We use best practices. Here we don't. But this is going out over a REST API, and the idea is normally I would have a service that would go ahead and do CRUD operations, create, read, update, and delete. But all I'm going to do is I'm going to go ahead and set the policy that this order is top secret. And so it needs to be protected as a top secret piece of information. And so if I come over here, and this time I'm going to go ahead and give a title to the order. We say, what are the rules of engagement? And Captain Kirk always says, we're going to set our phasers to stun. And if I go ahead and create that order, you'll see what's happened is the Interceptor has gone ahead and looked at that policy, and that decorator that I put on that class told the Interceptor that this is top secret data and it needs to be protected corresponding in concert with what top secret data is. So it went ahead and transparently behind the scenes took the order beforehand and went ahead and turned it into an encrypted document. So nothing goes out to the server. So right here, everybody kind of says, well, isn't this kind of what HTTPS does? And there's some really big differences that are going on here. And it's subtle if you haven't been exposed to the encryption world before. But what's happening here is the only way this data can be decrypted is with the private key that is on my client device. So nobody else in the world can read it except for the person that generated the data. So the data is, go ahead.
Can I hold you for a second? So
sure.
If your client is encrypting data, then the client has to have the key, and the key can be accessible. You could unwind the JavaScript and figure out how to make the key.
Yeah, so there are techniques with the Web Crypto API, and we use some very fancy things that I can go ahead and send information out on this. But the idea is that what you've talked about is how do you keep browser secrets secret, and there are certain techniques between the Web Crypto API and then using a trick with iframes and web workers to go ahead and actually create a different domain that allow that to be very, very difficult to do. It is a little bit safer if it's not in a browser. If it's on a mobile device, it's a safer environment, but you get a much higher degree of protection here. And the other part of that I kind of always call out, because endpoint security is really, really important. And you want to go ahead and make sure that you pay attention to endpoint security. But we're still talking about privacy mainly. So we're talking about not even a malicious actor, but just the way things are designed in general. This is the same thing that happens with WhatsApp or Signal, for example. So let me pause there, and this is an area we can dive into detail. Do you want to kind of go further down, or do you want me to keep going?
One thing before you go too far off track, you mentioned that at first glance, you would say, what about HTTPS? Isn't that what this is supposed to do? Can you expand on why, what that doesn't cover that this does? I think I have an idea, but for the audience.
Sure, it's a good question. It's very common. So let me pull up.
We also have one more question on the YouTube chat. Whenever you get a chance, I'll read it to you.
Okay, cool.
After Austin's question.
I love questions. So
be careful what you wish for, Rob.
So questions make it much more interesting. So if you guys have heard of Signal, okay, Signal is probably the best known end-to-end encryption application, and basically the way they got famous is the guy that invented is kind of, at the risk of offending some people, he's a little bit of a tinfoil guy, kind of tinfoil hat kind of guy, but it got picked up by WhatsApp, and WhatsApp is what eventually Facebook bought, and the founder of WhatsApp left Facebook recently because of how Facebook was treating it. But one of the ways that WhatsApp really took off is that they went ahead and said, right now, your text messages can be viewed by your government, and they can be viewed by all sorts of people. But it turns out that WhatsApp started to really take off outside of the United States and China, et cetera. And in WhatsApp, they have the full end-to-end encryption method. And I'm going to explain why that doesn't work for most SaaS applications, but just bear with me to kind of go through first what happens. So in this, what's going to happen is, I don't know if you can see that animation coming over the video, but the data gets encrypted on the client, and even the cloud service provider cannot decrypt it. So in HTTPS, it's encrypted on the wire, but as soon as it hits the server, it's decrypted. And then it goes ahead and it often gets passed around. Sometimes it gets encrypted in the database, but the thing is that it's open and available in plain text, and it's passed on with partners there. So here the idea is that if taken to its extreme, you would not even be able to have your cloud service provider look at the data at all. And that's the way WhatsApp and Signal works. So I'm going to stop and ask for a question here in a second, but the next question that people are thinking about is, well, the obvious thing is, doesn't that just make the cloud dumb? Like if I can't do anything in the server, all I've done is I've made the data dark to the cloud. And there's another peel of the onion for us to talk about there. But let me pause and just kind of take questions on the distinction between HTTPS and end-to-end encryption.
Yeah, I think that makes total sense, but that only really works for like a P2P, right? Like a peer-to-peer type scenario, right? If you need the server to take action on that data, you do have to decrypt it. Right, exactly. And so that's, these are the perfect, you're teeing up the perfect questions for me. So
that's why we keep them around.
Yeah. So a really good example of this is let's say I want to upload files to the internet. I want to go ahead and use service like Drive or Dropbox, et cetera. And I don't want their racy pictures that I don't want, spread around. So I really want to go ahead and make sure that they go from one point to another. But I like the fact that my cloud service provider does a virus check on each of those, because it's very easy to go ahead and get viruses on there. So what I'd like is, when I upload that file, I would like the cloud service to be able to run a virus checker on it one time and go ahead and make sure that there are no viruses in there. So that is a perfectly legitimate example of where I would like to give an endpoint, in this case the endpoint is a service, permission to go ahead and decrypt the data. The difference is that I can actually grant or deny that access. So I can go in, I'm not suggesting anybody actually does this other than software developers, but I can go ahead and say that I'm going to give permission to the virus scanning service to decrypt the data one time and one time only. And
so you would basically like whitelist just that service, not any service?
Yeah, exactly. And so part of this is each service has an identity, and the identity, we think about identity as username and password, but this is a cryptographic identity. They have a key that's mapped to them. So what we do is we can go ahead and say, this service is whitelisted, very good example, and it can go ahead and look at that data. And even more importantly than actually the access, probably the biggest thing is every time it accesses the data, it leaves a breadcrumb, it leaves a trail. So I have a complete audit trail of every time the data is decrypted. And there are malicious ways to get around this. You can decrypt the data and store it off. But really what we're trying to get at is to build into the system a framework that makes it really easy for us to set this up in a way that it's hard to write software bugs that will get around it, where it's easy to audit and it's easy to go ahead and test. And so by having this mechanism where anybody that looks at the data has to be given permission, has to leave an audit trail, and ultimately I can flip the switch to turn them off, that's what we're trying to accomplish.
On the same point, though, you did mention, like, I can grant, I can give it a one-time use token to decrypt the data. As soon as it decrypts the data, it can do whatever it wants with the data. So
it can, yeah, it can, and so this is, that's why I said, maliciously, once you're out of the encrypted system, you are, obviously can't do it beyond that, but now you have the basis for contractually adhering to GDPR, California Consumer Protection Act, to SOX, to HIPAA, and you have a very good protection against insider threat. A lot of these different types of breaches and privacy issues go away. You obviously, even with Signal, with WhatsApp, you can take a picture of the decoded text on the end device. I mean, there's no perfect secrecy, but what we're trying to do is we're trying to set up a system that works in this modern economy that gives us a hope to go ahead and control data. So I don't want to get spun up too much on that. What do you guys think? Should we keep going down this path or pop back to kind of the nerdy, how does it work kind of stuff?
Bonnie, did the question get answered from the stream?
Well, there was a question. I didn't want to say it because I told Zama on the chat that I feel like Rob's going to get to this any second now, and I don't want to interrupt him because I think he's going to cover this. But I'm just going to throw the question out there, and then if you want, Rob, you can circle back around to this later because I also am adding a little question of my own. Awesome. So Zama's question was, how can the server decrypt it? But also then my question, which might actually be a good question for the end of this episode after everything is, but I'm just wondering about this. So if they know how you're doing your encryption, then you would think that the bad guys would try to find a new workaround. Like every time you come out with something to keep them from hacking it, they're going to try and hack your protection. So then if I use this, then like coming on AngularAir, aren't you telling them like how it works and making it easier for them to, I mean, I'm glad you're teaching us, but I don't want you to teach the bad guys at the same time. And how can we protect ourselves?
Yeah, I mean, that's literally the entire cybersecurity industry, right? Is once you figure out something, right, like the bad guys have probably already figured it out and you need to adapt and change. So, well,
that's why I said it might be good to circle back around to that at the end, because I don't want to tear you off track. But also, Rob, I'm getting really worried about your laptop battery, and you should plug it in. It's stressing me out, man. I don't want to lose you. There's so much to learn.
1 second. All right, 1 second. Keep going. I'm happy doing that. I'm really glad that you're on top of that. So a couple of questions there, because we can go down this forever, and I'll pop back out in a second. But one of the things about cryptography is if you can go ahead and break cryptography by knowing the algorithm, it's not good cryptography. So the idea here is that that you can know the algorithm, but you still can't go ahead and break it. And so the hard thing about starting a company that deals with encryption, and if there are any like crypto nerds on the call, is kind of proving it. So I mean, there are definitely nerds on the call. Yes, crypto nerds are a special category. Trust me, it's like beyond that. But the idea is that actually, I'm not going to get it from there. So, but this has been audited and presented at the ACM, and all the different things that you'd kind of expect. And we basically have set it up so that you can know the algorithm and you're not going to be able to break it. The thing is if you know the private key, you can break it. So it's the private key that really matters in all of this. So I'm not gonna dive into that because I think we'll be down a big rat hole. I'm gonna pop back out, but I will come back to this at the end, and we can look at how much time we have, because I'm noticing we got about 15 minutes. So let me pop back. So kind of coming back to this, the last thing that I want to talk about is just this idea of policy. And, we kind of said policy-based encryption, right? So we went ahead, and if you think about any type of software application, if you probably are going to do a data model. And when you do that data model, there's going to be certain information that it has regulations applied to it. There's certain information that's going to be very sensitive. And what we want to be able to do is we want to be able to set up a data privacy policy. And actually, we talk about this concept of a data privacy architecture, and you want it to be policy driven. So here I kind of give a couple of examples of where, hey, intellectual property, I just might want to call that private. A medical record, I want to call that personal health information. A contract with a big company, I might want to call that legal information. And so the idea is that what we want to get in the habit of doing is just classifying the protection level of different types of information. And we want to do that declaratively. So if the concept of declarative versus imperative programming, imperative is where you say, how does this work? Declarative is where you just declare what you want to have happen. CSS is a very good example of declarative versus imperative programming, where I can go ahead and say, I want the text in the center of the screen. And it's left up to the browser to go ahead and figure out how that text is in the center of the screen. So we want to do that same thing when we get into the privacy realm, because if we relied on thousands and thousands of developers to each write their own algorithm for centering text on the screen, we would have a lot of unusual definitions of centering text, okay? But the idea that we have a very simple way that we can say that is one of the ways that it makes it work. It makes it certainly a lot more productive, but it also makes it easier for a designer to look at it and say, yeah, that's what I wanted. We can test it, we can audit it. It's self-documenting, all those different things. So that's the whole idea behind policy. I'm going to go ahead and I'm going to go real quick through this repo. So this is another good way, if you're kind of curious about this, you can go out to the Getting Started Angular repo on Iron Core Labs, and there's a sample application, and I'm just going to do an npm start here, and I'll show you how this works with a different example. And then we can go in and take more questions.
Is this both client side and server side that these policies are working through?
So mostly it gets encrypted on the client side. There is a small cloud service that is kind of does some of the basically what's called transforming the data. But most of this is done client side. So I'm going to go ahead. I've got a little application here where, if you guys are old enough to remember the original Star Trek, the idea is that it was kind of the first science fiction series, and this crew would fly around to different planets, and Captain Kirk was the captain of the Enterprise, and he would assemble a set of people to go down to the planet's surface and explore it. And he would give commands to the away team. That's what they were called. And we didn't want the bad guys intercepting those commands. So, for example, he might say, rules of engagement, set phasers to stun. And I'm going to go ahead and encrypt that order. It's kind of the same thing we saw in the stack blitz. You can go ahead and clone the repo and see how that works. But if I go ahead and I say, okay, I want to look at this from a different perspective. So I'm going to log out as Captain Kirk, and I'm going to log in as Mr. Spock. And what we see is that, hey, Mr. Spock can't authorize this message at all. He can't decrypt this message. So, and the reason why is Captain Kirk hasn't added him to the away team yet. So I'm going to come back and I'm going to show you the mechanics of how we do that. But I'm going to pause here for a second and kind of call out why this matters. So the way encryption works today is that when you encrypt data, you generally have to know who you're encrypting it for. And that actually doesn't scale very well. Like, I might want to encrypt my personal health information, but I don't know that I'm on my way to the emergency room to Seattle Grace Hospital, and I would like them to be able to look at the data right before I arrive at the emergency room door. So the decision of when to protect my data versus who should be able to access it is actually distinct in time. So I want to be able to protect data and then later on be able to change access to that data. And that concept is very familiar. It's called access control. This idea of, you share a resource to a group, and later on you go ahead and say who's in the group. Access control is often talked about a who and a what problem. So the what is the data, and the who is who can access it. What's different here is we're doing this all mathematically in encryption. There are no software rules. So it's a lot less vulnerable. There's no software bugs to exploit. Everybody's doing it in a standard way. It's very fast and lightweight. So I'm going to go ahead and add Spock to the away team. I'm also going to add Redshirt. And now I'm going to move over to Spock. And what we'll see is that Spock can now decrypt that order. Redshirt can as well. And if you guys have watched Redshirt, if you've watched any Star Trek, anybody in a red shirt is destined to die by the end of the episode. So Kirk is going to go ahead later on. He's going to say, hey, I shared this data with Redshirt, but he didn't make it back. So I'm going to remove him from the group. And if I go back as Redshirt, I actually have not touched the underlying data. All I've done is changed the cryptographic permissions, and Redshirt can no longer look at the data. So that was like a laser speed talk through the GitHub repo. But if you guys are interested, you can clone it, and there's pretty good documentation on it. So I'll stop talking so fast and open it up for questions.
So the what is the iron part of it providing then for us? Is that encryption, the decryption, and the management of those policies? Is that correct?
That's correct. And it's actually, there is a new type of encryption that it's actually not new to academia. It's actually been talked about for 15 or 20 years, and it's called proxy re-encryption. And it's the part that implements groups. So the big thing that IronCore is providing over kind of standard encryption technologies is that, and I know that this stuff is some pretty deep stuff, but like if you're familiar with PGP, let me see if I can find a PGP example. I'm not going to find it, so I'll just talk to it. So if you're familiar with PGP, the idea is if I'm going to share sensitive data with 15 people, I have to encrypt to 15 different public keys. And that basically falls apart at any scale. So the part that IronCore does is it allows you to encrypt to one key, which represents a class of data like personal health information. And then there's something called a transform key that goes ahead and converts the data from PHI to who can read PHI. So big hand wave, but lots of documentation on the site where if you're curious about digging into that.
So really kind of to distill it down is we've got Angular application leveraging HTTP interceptors to handle all the GET requests and POST requests to then go and say the data that's going over the wire, we are going to encrypt it or decrypt it depending on what direction it's coming. And then based on the user that's logged into our app that we're tracking, we're going to identify whether or not that decrypted data should be decrypted in that HTTP interceptor so that our application can use it. Does that sound correct?
That's correct. Yeah, and a little bit of a couple little nuances there. It's that it's going to be encrypted throughout the system. So like in Facebook's example, in Cambridge Analytica, Facebook, when they had a partner, they would contractually have to store the data in an encrypted format. So Facebook would be able to see that they had passed the information on to Cambridge Analytica. They'd be able to see how Cambridge Analytica was using the data, and they'd be able to revoke it. So it's not just over the wire, it's the lifetime of the data. And the decryption on the client only can happen because there's a private key that's kept on the client that doesn't go anywhere else that allows them to decrypt the data.
And then what's the validity of that logic that does the decryption in terms of lifecycle for we get down the road and that code gets updated and now all of a sudden I can't decrypt my data that's out there stored. Is that a possibility that happens?
Not really. I mean, anything is possible, but this is like, So if this is actually the core IP underneath this is just like, it's built on top of public key encryption, but these algorithms are like very, very carefully vetted, and they're small. Like every line of the code is mathematically proven. And so this is not code that gets easily updated. So if on cryptography, I am going to take you, it's kind of a different world. This stuff gets audited and put out into the community, and we have a professor of cryptography that's on our board that reviews it. So none of this stuff gets done in a very lightweight way. The actual algorithms, the underlying cryptographical algorithms, are all open source, so they get community review, etc. Very, very hard for that to happen.
All right, cool. That makes sense.
All right, so that's not coming up for some reason. ACM is down. So
you should turn off your screen share and end the show with your face.
All right, let's do that. We went in.
Oh no, that's my face.
How do I? All right.
Yeah, you're it. Hi. That was awesome.
Okay. Yeah. I'm good. That was really good. Yeah, it was really fun. It flew by, man. So I had, it's a very dense topic, so I apologize if it got fast at the end, but there's good backup materials on it. And, my one message here is that if you're a software developer, this matters. It's like, we're building stuff that really, a lot of people are dependent on, and, we're in a situation now where, it's going to be driving us around pretty soon. So it's worth learning this stuff.
Absolutely. It's like vitamins.
Yeah, I think even from a standpoint of like you're building an application and you have data that you're saving for your users, and maybe you don't have intent on sending it out anywhere or doing that sort of sharing of or whatnot, but just the storage of it. If you're storing that data on your end to store that user's data, can you store it encrypted, provide your client, and then they'll only access to it. I think it's a solid direction to be thinking about.
Cool. And great questions. Thank you guys for, that was fun.
Yeah, Austin had some good ones. He's our resident troublemaker.
Is he? I thought you were I had you pegged as a troublemaker for sure.
I mean, I'm a troublemaker too, but in a different way.
I would say you're a resident critical thinker. So.
Yeah.
Okay. Yeah. That's very diplomatic, Justin. I can see you're the diplomat, aren't you?
I try to balance.
It also probably helps me that I've been in the cybersecurity industry for about 10 years now. So
there you go. Okay. Yeah, great. Well, it was really insightful, and thank you guys so much for having me. And
yeah, for sure. Let's do some picks here real quick before we wrap up.
Okay.
Has any picks?
I have a pick
on the list. Alyssa first.
Oh yeah, I wrote a blog post last week about Angular 7. Just obviously the features, but also if it affects like the Kenda UI library, and also kind of outlining some fake features that were circulating. So yeah, I put the link somewhere. Yes, I sent it to you, Justin. So it should be in the notes. But that is all I have.
Awesome. Hey, do you want to be our guest for an episode on talking about what's new in Angular?
Yeah, I was thinking about that when Mike said that, but I'm going to need backup. So if one of the other panelists want to be like my co-guest, that would be.
We're all here. We're all your backup.
I can see you ganging up on me, Bonnie.
We will do. Yeah. Why do you think we want you in the hot seat? This is going to be so fun.
All right. We'll figure something out. All right.
Or we could co-present it all.
Raise your hand if you've got picks. I'll then start going down the list there. Okay, Bonnie. How about Bonnie?
I want to pick a person again, and I know I do this once in a while because I meet really cool people. I meet a lot of really cool people.
You're gonna pick me?
No, I already know you're already cool. Everybody knows about you. No, this is actually a developer that I worked with on a project, and he is very cool. And he only has 287 Twitter followers, and I want you guys all to go follow him on Twitter because he's pretty amazing. His name is Sammy. And his Twitter is Sammy IS_ME, like Sammy is me. And he's great. He's a junior developer. Well, actually, he's not a junior developer anymore because he's been doing some really cool stuff. But go follow him on Twitter. He's really cool.
Cool.
But don't tell him why you guys are all following him on Twitter, because we're not going to say anything to him. I don't think he's watching this, so just do it. It'll be fun.
All right. We got to get him to watch this. What? Anybody else have any picks? Oh, Mike. Okay, Mike.
I got one. I've got a book. Just finished Off to Be the Wizard by Scott Meyer. It was a rather interesting tale, and apparently just found out it's also part of a series. So I was going to go check out the rest of those in that series as well.
What genre is it?
Yeah. Is it like funny? Is it a technical book? Is it a story book? Is it science fiction?
Science fiction.
Give us something here.
Science fiction storybook.
Science fiction storybook.
Does that make sense? We're good?
Yeah.
It was really interesting. Yeah. I don't want to give it away, but yeah.
What's it called again?
Off to Be the Wizard.
That's clever.
Yes.
Cool. All right. Well, Rob, thanks so much for sharing your time and coming on and doing the episode. We really appreciate it.
Thank you, guys. You're great hosts, and I appreciate everything. Thank you.
All right. Till next time. See you.
Later.